In the previous two videos, we talked a lot about the relationships between arcs and angles that arise when you are dealing with circles. But in this video, we're going to switch gears and talk more about segment length relationships. And these are the main two. When you have intersecting lines inside of a circle, then part times part is equal to part times part. When the lines meet outside the circle, then it's all about the outer part versus the whole thing. And it turns out that the outside times the whole is equal to the outside times the whole. So looking at A and B, that would be A times A plus B is equal to X times X plus Y. So that's what we're dealing with here. So see how this is outside the circle? So that means that we're dealing with the situation where the outside times the whole thing is going to equal the outside times the whole thing. The more obvious part is the part here at the bottom. So I'm going to deal with that first of all. So I've got the outer part, which is 9. All right, so that's going to go right here, times the whole thing, which is 9 plus 16, so that's going to be 25. Now, what about this upper part right here? Now, the outer part is X, but guess what? The whole thing, there's no other part. When we were dealing with the 9, we had the outer part, and then there was some more that went inside the circle. But in this case, this is a tangent, so that's it. The outer part is also the whole thing. So I'm going to put X for the outer part, for the outside, and I'm going to put X again for the whole thing. So that gives us X squared is equal to whatever 9 times 25 is. 225. Oh, look at that. That's a perfect square. So to get X by itself, I'm going to just take the square root, and that's going to be 15. So X is 15. For number 14, we are dealing with that same situation. The segments are meeting outside the circle, so the outer part times the whole thing is going to equal the outer part times the whole thing. So looking at this segment over here on the left, the outer part is the 10. So I'm going to start with that, 10. And then now it's going to be times the whole thing. Well, the whole thing is 18. It's not 10 plus 18. 18 is the whole thing. You can tell because of this bracket that stretches from beginning to end of this whole thing. So 18 is the whole. Now, looking at the other segment, the outer part is this 6. So I'm going to go ahead and put 6 for the outside part. Now the whole thing is all of this. So this is going to be X plus 6. A common mistake is to put 6X, but that would be 6 times X. All right, you have to add these together to make the whole. It has to be 6 plus X or X plus 6. Anyway, so 10 times 18 is 180. And then here you have to do some distributive properties, so that'll be 6x plus 36. Then probably best to subtract 36 from both sides. Okay, so now you've got 180 minus 36. So that's 144 is equal to 6x. And then you turn around, and what you do is you divide both sides by 6. Alright, I wonder if this goes in evenly. Divided by 6. 24, look at that. Alright, whoever wrote this test was very nice. And we're not getting any decimals. Helps us to feel secure. Anyway, x is 24. Okay, moving on. Number 15. Alright, so this is the other situation where the segments are intersecting inside the circle, which means part times part is equal to part times part. Okay, so here's one part and the other part. So I'm going to have 6 times 4x minus 8. Alright, and then here's the other part times part is the 4 and the 18. So that's going to equal 4 times 18. So a little distributive property here, and that'll be 24x minus 48 is equal to alright, 72. So let's add 48 to both sides, and that'll give us 24x is equal to so that's 120. Okay, and then we will divide both sides by 24. So x is equal to 5. Here's another segment relationship that's sort of common sense. If the chords are congruent, then the arcs are congruent. So you can see that these two chords are marked congruent. That means that the corresponding arcs must also be congruent, which means that 8x minus 20 must equal 4x plus 28. So I would start by subtracting 4x from both sides, get those x's together. That's going to give you 4x minus 20 is equal to 28. Then when you add 20 to both sides, then now you have 4x is equal to 48. Then you're going to want to divide both sides by 4. And that's going to give you x is equal to 12. So x is 12. That's great. What's next? Now we need to find the measure of arc BC. Okay, arc BC is represented by the expression 4x plus 28. So let me just portion this off real quick. So the measure of arc BC is given by 4x plus 28. But x is 12. So this is 4 times 12 plus 28. So that's 76. So the measure of arc BC is 76 degrees. Okay, now next we want the measure of arc BED. Okay, so arc BED is like this. It's the major arc that goes from B through E and around to D. Okay, well, here's the thing. We just found the measure of arc BC, and that was 76. So that means that this arc right here is 76. Okay, but we already knew that both of these arcs are congruent because of symmetry. If the chords are congruent, then the arcs are congruent. So that means that arc CD is also 76. So that means that this red arc, BED, is the rest of the entire circle. So if I take 360 and I subtract the 76's, that should leave the red arc. So that's what I'm going to do. If I take 360 degrees for full circle, minus 76 minus 76, that should equal the red arc. So the red arc is going to be 208 degrees. Okay, so that's 208 degrees. Finally, we're supposed to find the measure of angle BCD. So angle BCD is this angle that's what's like the one angle in the whole picture. So look, we're back to this situation, y'all. We're dealing with an inscribed angle. Vertex on the circle, the angle is half the arc. The arc is 208. So the angle must be 104. Alright, it's half. So the measure of angle BCD is 104 degrees. Alright, now we're down to the last two questions. The next question is a review question that has nothing to do with circles. So I'm actually going to skip over that for now. I'll save that for the end. I'm going to go and do the bonus, which still pertains to the subject of arcs and angles and segments and circles. And that way, anyone who doesn't care about probability, they can just stop the video. Okay. So, let's see, what do we know? CE is a tangent. Okay, there it is. Angle E is 26, that's given. Find the measure of arc BC. Okay, so I can see why this is a challenging problem. So here's one thing to keep in mind. Okay, this is a diameter. Okay, that means we have a semicircle, okay, that is made up of arc BC and arc CD. Okay, semicircle. So here's the thing, these two have to add up to 180 degrees. So I'm going to call one of these X. It really doesn't matter which one. But then the other one is going to be 180 minus X. Alright, I think I'm going to pick the green one to be X. So if I call that X, then the red arc must be 180 minus X. So now I have an expression for both arcs. Okay, now we're dealing with this situation right here. So when you have the angle that's outside the circle, the angle is equal to the big arc minus the small arc divided by 2. Okay, so let's just write that down. So we're saying that angle is equal to arc minus arc divided by 2. Now in this case the angle is 26, so I'll go ahead and put that down, and that's going to equal the big arc minus the small arc. So that's 180 minus X. Okay, maybe I'll put parentheses around it to make it obvious that that's the first arc. Now minus the small arc, which by the way, this is the reason why I picked the small arc to be called X, is because if I did it the other way around, then right now I'd have minus 180 minus X. And I'd have to remember to do the distributive property, and I'd have to do minus 180 plus X. And a lot of students forget to do that. So by making the second arc just be X instead of 180 minus X, I don't have to do the distributive property, and we can avoid that common mistake. Anyway, back to the problem. So that all of that is divided by 2. So really, these parentheses aren't really doing anything. I just put it there so you could see big arc minus small arc. So if I can carefully erase these, then you can see I've got some like terms here. Minus x, that's negative 2x. So now what I have is 26 is equal to 180 minus 2x divided by 2. So what I usually do is I will multiply both sides by the denominator. So I'll multiply by 2 on both sides. Okay, I could have divided both of these by 2 and gotten 90 minus x. Either way, anyway, I'm going to get 52 is equal to 180 minus 2x. Man, I'm messing up. Let me just do all of that again. Okay, I'm going to get 52 is equal to 180 minus 2x. So, trying to get x by itself, so I'm going to subtract 180 from both sides. So that's negative 128 is equal to negative 2x. So then I just need to divide both sides by negative 2. Okay, I guess I don't need to show that. So that is going to give me 64. Positive 64. Alright, so x was the measure of arc CD. So I now know that CD is 64. So the other arc, BC, is going to be 180 minus 64. So that's going to be 116. Alright, together they add up to 180. But the thing that we were actually supposed to find is arc BC. So that is 116 degrees. Okay, so if you came for the relationships between arcs and angles and segments in a circle, then for you that's the end of this video. If you were a student in my class and you took this test and you got this question wrong and you want to know why, then you're going to stay tuned and watch me do this probability question. But again, this has nothing to do with circles and arcs and angles. So, you know, do what you need to do. So anyway, the review question. I love the ones that are given. In fact, let me zoom in on this mess. Alright, this vertical line means the probability of B given A. I always love these problems because probability is target over total. Okay? At its heart, that's what probability means. Now, when you have one of these given problems, then whatever you're given is the new total. And the first part winds up being the target. Alright, so it just fits the target over total perfectly because you have the target and then the total. Even the vertical line almost looks like a fraction. So it just perfectly fits the idea of target over total. But the confusing part is you sort of need to work backwards. Don't start with B, start with A. Start with the new total. So the total is A. So let's highlight that. So that means this is the total, 6 and 11. That's A. All right, I mean, I could highlight the whole circle if I wanted to be really thorough about it. All right, but who's got time for this? All right, so look, guys, so that's the new total. So when we talk about target over total, right now we just found that the new total is 17. 11 plus 6, that's 17. So that's going to be the denominator for sure. Now, what I encourage you to do whenever you have a given problem, highlight the total like I just did. But if I were you, I would immediately cross out everything else. This yellow A is the total. That means there is nothing else. It's the total. Nothing else exists. That will help you avoid mistakes when you go to think about the target. Because the target now is this B part. But that will not include the 15. All right? The 15 and the 14 are gone because A is the total. All right? Nothing exists outside of A. So when I talk about the target is B, I'm talking about one of these two numbers, either the 6 or the 11. Which one of these is B? It's the 11, of course. Okay, the 11 is inside of circle B, so it is still a B value. Okay, so when I say that the target is B, I'm talking about the 11. So that's why it's going to be 11 over 17. All right, so that's going to be the answer. All right, 11 over 17. If you really wanted to, you could write that as a decimal or a percent. 11 divided by 17. Okay, is this craziness? So that's 0.6471. Okay, which I could write 64.71%. But 11 over 17 is fine. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.